Okay, so there's one last example that I want to go through in talking about class inheritance for Python. Now, there's a lot more we could go into. There's ways you can inherit from multiple classes. We're not going to talk about that right now, but let's just focus on the fundamentals. So once again, you can see I have my network device class. It has an init method. It has an open method. It has a send method. It has a receive method. Now notice I've added this simple method, say_hello, that just prints out hello world. Now notice for Cisco iOS XE, I do have an init class. It does call its parent class using super. It then does set this platform attribute for Cisco XE. We then have our setup method. Similarly for Juniper, we have an init class. We have the invocation of super. We set the platform to be Juniper Junos. We have the setup. Now notice Juniper has its own local say hello method. Notice there is no super invocation method. There is no invocation of super here. So when we call the say hello method on Juniper, it's just going to execute this method from the local class. Now with Cisco iOS XE class, there is no say hello method. So what's going to happen with Cisco iOS XE? It's going to look in its class for say hello. It doesn't find it. It's then going to traverse its parent classes using the method resolution order. It will find this say hello in its network device parent class and execute that method. And you can see the string that gets printed there. And then you can see the code that I execute. So let's go ahead and run this and watch the behavior. Okay, so I'm going to put a breakpoint at line 94, execute that. Okay, there's Cisco iOS XE, there's Juniper. Okay, so now if I do con2.sayHello, so con2 is the Juniper device. If I call the say hello method on Juniper, you're going to see that we have that method. Now if I call con1, that's the iOS XE. If I call say hello there, you're going to see that it's going to run the say hello from the parent object. And we could look at the line numbers of like the parent class to actually find that code. And you could see, okay, that's what it looks like in the network device class. And that is what we saw when we executed that on Cisco iOS XE, i.e. it's running the say hello method from the parent class. Now also, we could look at the platform attribute, which we know got initialized in the init method that's local to Cisco iOS XE in this case. So we can see that that did get it set in its local init method. But then if we look at the host attribute, we can see that that also got set. Where did that get set? That got set in the init method of its parent class, which happened here, which happened when we invoke super, because one of these arguments we pass in is the host argument that gets passed up to our parent class. And we look at the parent class, you can see the arguments we pass in here are host, username, and password. So those three attributes get set in the parent class, and the platform attribute gets set in the child class. And we can see that that is all happening correctly. So the main takeaways are you have this hierarchy of classes. It starts with your local class, and then it goes to your parent class. And then there could be, your parent class could also have a parent. So there could be, multiple levels of depth to this hierarchy. We have this method resolution order where it looks in your local class for a method. It then looks in your parent class, and then it traverses up the hierarchy. We also have this super invocation for how do you call the parent class from the child class. So In this case, we wanted the init method to do something locally, which was set the platform attribute, but we also wanted to do everything that was done in our parent class, which in this case, which was set the host, username, and password attributes.